Hello everyone, welcome to FameWorld Educational Hub, myself Aishwarya Saxena, and today in this video I am going to demonstrate a project of Python machine learning, that is filtering images using Python machine learning. On this channel I have already demonstrated two projects before also, that was in this particular playlist, machine learning projects, and where I have discussed two.
Try Les Mills Plus.
First one was the mushroom classifier project and another the lung cancer detection project. So if you need those kind of projects, so they are available here. In today's video, I am going to discuss about filtering images, and that is going to be using Python machine learning. So I am just going to give you one more information that I am actually having this particular project prepared for you with the report synopsis PPT. So the demonstration of this particular project I am going to show you right away. I will be demonstrating everything about this project in this particular video, and I will be sharing with you some information with the help of which you will be able to get this project completely. So watch the video till the end, because I will be telling you that how you can access this particular project or you can get this particular project simply. So I will be also explaining and sharing the resources which are actually related to this particular project of filtering images. So let's start. First of all, I am just opening this project file. I am just double clicking on it and I am using the PyCharm. So do not worry that how to install the PyCharm and how you are going to work with it. I will be telling everything. I am just going to open this particular file right away on my PyCharm, and then I will be telling everything till the end. So please stay tuned till the end of this video. You will be getting all the information properly. So here I have created this particular project, and this is simply for you to understand, and the different libraries and all whichever are used here, or whatever are the scenarios in this particular project, everything I am going to explain in this video. So if we talk about, first of all, let's know that what is basically the filtering images. So filtering images basically is a technique for modifying or enhancing an image. It is basically used for many applications, for smoothing, sharpening, removing noise and edge enhancement, and it makes possible several useful tasks in image processing. So here we are using the image processing module OpenCV. I am just going to show you all the resources, and even I will be sharing their links in the description of this particular video. So you will be getting all those description links in this video. You will be getting help out of it. So it is opencv.org, which is the official website of OpenCV, and this module we are using in this particular project. This is the official website and it has a lot amount of information for you. GitHub link, online documentation, they are providing the tutorials and all. So this is the module which we are going to use in this project, and how it will be installed, that also I will be telling you. Please stay tuned, as I said before. So one module which we are using, that is OpenCV, another is NumPy, and another one is the Matplotlib. So the Matplotlib is basically used for the graphs and all. So when you are having visualizations in Python, so you can use the matplotlib.org. This is the official website, but you have to install this particular module into your system, and then only you will be able to work with it. So how it will be installed, I will be telling. And another thing which we are using, that is the NumPy module. So NumPy is nothing but the numeric Python module. I am just opening the official website of it. NumPy.org is the official website of the NumPy module, and it is the fundamental package for scientific computing in Python actually. And NumPy stands for numeric Python. It provides a lot amount of functionalities when we are using the images and all, images, when we are doing the image processing in the machine learning projects. So that time it is necessary to have the NumPy module engaged into it, to use the NumPy module into your project, because the NumPy module is actually having the concepts of array and matrices. And simply when we talk about the images, so the images when we are using in our project, so those OpenCV images are actually converted to and from using the NumPy only. So that is the reason. Another thing, the Matplotlib, as I said, so we will be plotting some graphs and all, and also the output which we will be taking, that will be in the plots. So that's why we need the Matplotlib here. We will be using different filters here, and which will be actually coming through the OpenCV only. So the image which we are using, let me show you that also. This is the image which we are going to use in this particular project. I am just opening this. It is a simple image. You can take whichever image you want. It's not that you have to take this image only. You can take whichever image you want. But yes, if you will be asking me to share the code of this project, so obviously the complete code and the documentation you can get. For that, how you will be getting it, please stay tuned till the end. Anyways, so here, like as I was telling you, that a filter can be applied to reduce the amount of unwanted noise in a particular image and all. So you can say the objective of this particular project is to reduce the amount of noise in an image, understanding noise suppressions, smoothing, and filtering simply, and understanding how to enhance the edge of an image. So understanding adaptive contrast enhancement and the filters, simply these are the objectives of this particular project. So as I told you that the libraries which are there, like the NumPy, CV2, that is the OpenCV, the Matplotlib is present here. If you want to install them, they are really simply installed in the system with the help of pip command. Pip stands for Python Package Installer. Okay, so now I'm going to start the demonstration of this project, and in between I will be telling you about the things which actually are used here and how it is working. Those also I will be demonstrating. So let's start. So in this project, basically we are going to check whether we can use more detailed filter or not, and it might also help to check whether any smoothing effect can increase, and what improvements techniques can be done so that the filtration of the image can have more options, and to reduce more sound effects or you can say noise effects to make the image protective. The filters which we are going to use here, those are the mean filter we will be using, Gaussian filter, median filter, conservation filter, and Laplacian filter, and frequency filter. So these are the different filters which we will be going through here. Here you can see, firstly we have imported the modules. Here the PIL, that is basically the pillow module. Pillow stands pillow is basically the library which is used for the images. So basically when we are using CV2, so we are actually using mainly CV2 here. Pillow is actually just imported here, and pillow is actually the image module. Okay, so when you are using the images in the Kinter and all, then also it is used. I will be explaining about it in detail today only, in this video only. So firstly we are just importing the image which we are having. We have just taken the image in the same folder. Here I have created the folder filtering, and inside that p.py is the project folder of our file, the project file, and pic.jpg, that is our image which we are using. I have already shown you that image. I am again opening this image. You can see it is here. Whichever you want to use, whichever image you want to use, just keep it in this particular folder. This folder means whichever folder is containing your project file, the same folder should contain the image. So here to read the image, to open the image, we have taken imread. So cv2.imread. cv2 is simply the OpenCV module. We have to import it with the help of cv2, and imread is used to read the image. So we are just reading the image. Then cvt color, that is simply the convert. So you can see everything which we are using here, that is simply in the cv2. That is cv2 means OpenCV we are using here. So we are just converting it into the HSV format. So cv2.color BGR to HSV we have taken here. The complete OpenCV series is present on my channel itself, on this channel. So OpenCV tutorial is present here in case you want to learn about OpenCV in more detail. So you can
question did you build a website?
There are 13 in detail videos. I will be definitely sharing the link of this particular video playlist also in the description. Okay, coming back to the project. So here we are converting in different formats, and how it is working, that in detail I have discussed in that playlist. In case you need, you can watch it. So the blurring of the image, because we will be just converting the images into grayscale again and again to check the effects on the colored image and the grayscaled image itself. So here you can see subplots we are using. So plotting is actually done with the help of the Matplotlib. So Matplotlib is basically the module which is used for the graphs and all, or you want to create the plots. So you will be able to create that subplots here, and that subplot we are using from plt.subplot. PLT we have just taken the alias of this pie plot. So that is coming from the Matplotlib, and we are just creating the subplots here. plt.show is used to simply display the output or window. Then here you can see the image will first be converted into the grayscale. As I said that we will be converting it into multiple times, we will be converting it into grayscale to get the better outputs. And here then the Gaussian filter is applied. I will explain it more clearly as I will run it, so you will be able to understand it. Stay tuned, don't worry that how the things are going, as I will be running the project, so I will be explaining it in more detail. Right now I am just showing you the code. So to apply on grayscale, you can see this is here, like how you can just apply the Gaussian filter. So Gaussian blur is here, that is also coming from the CV2. So on the grayscale and on the colored, both we are applying every time. Then the median filter we have applied on the colored image and again on the grayscale, that is also coming from the CV2, that is the OpenCV itself. So conservative filter we are applying here for the smoothing. So here you can see this also we have applied. And then after that we are just applying the Laplacian filter. So Laplacian filter it is, and here I should be added anyways. So this Laplacian is again coming from the CV2, that is the OpenCV itself. So here like everything you can see it's visible properly in the code. We have commented everything, like it is present, the comments are present here. Frequency filter then is applied here, and after that, like firstly on the color, then in the frequency filter the low and high frequencies are actually measured, so that is also calculated. So firstly I am just going to run this project. I will be running this project, then I will be explaining it in more detail. After that I will be telling that how you can install these particular modules which are actually used here. So I will be explaining all these installation also till the end. So I'm just going to run this project. I'm just right clicking on this PyCharm. I will be telling about PyCharm also, and the download link I will be sharing in the description simply. So right now I'm just going to run this project, and here as I have run it, you can see this particular first figure is available in front of you. So here as I said that we are going to use multiple filters. So here you can see the original image. Now this particular plot is actually coming due to the help of Matplotlib subplot. Here the mean filter we are using, and mean filter is used to blur an image in order to remove the noise. So blur function from OpenCV can be used to apply a mean filter to an image simply, as we have done here. Then I am using Q for quit. Actually Q we have mentioned in the command, like I have mentioned in the code. So if I will be pressing Q key from our keyboard, so this will be closed and another output frame will be coming. So here you can see another window has opened, and it is again the mean filter only which is coming in the grayscaled mode. So the colored output and the grayscale you can see now. Then I am pressing Q and you can see another output is coming, that is the Gaussian filter. So the Gaussian filter is similar to the mean filter. However it involves a weighted average of the surrounding pixels and has a parameter sigma simply. So Gaussian filter blurs the edge of the image like the mean filter, but it does better job of preserving edges. Then the same thing we have applied on the grayscale of the Gaussian filter, we are applying on the grayscaled image. So you can see the original grayscaled image, that is the black and white, and the Gaussian filter applied grayscaled image. Then we are just going, I am just pressing the Q again, and you can see we are getting the next output, that is the median filter. So the median filter calculates the median of the pixel intensities that surround the center pixels, and it then replaces the pixel intensity of the center pixel simply. So this is from the colored format, and now this is the grayscale form of the same image in the median filter applications. Then here like you can see the conservative filter actually we are applying, and like Laplacian filter it is actually, but here the medium like you can say in between the intermediate results are also coming. Laplacian of an image highlights the area of rapid changes in the intensity and can thus you can say be used for the edge detections even. So here the frequencies are actually you can say the low and high frequency are there, and this frequency filter like when applying so an image is important to like simply it is converted to the image of frequency domains representing on the low and high pitches of the frequency. So now here the low pass filter you can see, as I told you, those were the intermediate results, and this is the low pass filter output, and this is now done. So here you can see this way we have just seen that how this particular code is working, how the like image will be converted into the gray scale. We are using this BG to gray, BGR to gray, that is the blue, green, red to gray, to convert it into grayscale module, like a grayscale format. And then here also the Gaussian filter we have applied. So again we are just taking the original and the Gaussian one. So this is the code you can see, and as I said that I will be telling about the report and PPT and all everything. So in this particular project, like I am having this project ready for you. In case you need it, you can contact me. And here you can see like the synopsis, report, PPT, everything I am having with the like project simply. So I am just going to demonstrate, like show you all these things once in this video also. So I am just opening the synopsis, report and PPT. Do not skip the video, because if you will be skipping this video, obviously much more information you will be losing. So kindly stay tuned till the end, because I will be telling how to install those modules, how to work on the PyCharm, and every related detail I will be sharing till the end of this video. So please stay tuned. Anyways, so here you can see that this is the synopsis, and the synopsis is like containing all the information like it should have. Simply the introduction, objective, scope, background, hardware, software requirements, conclusion, bibliography of the project. It is ready with me. In case you need, you can contact. And here every detail is properly mentioned. Even we are working like on the project developments also. So if in case you need any other project apart from this, you can contact us on the given number. And now this is the simply report of this project. Let me show you that also, so you will be getting the idea that how it looks like. And here you can see this is the report in which all the things, the coding and its output and everything is mentioned in a very proper and detailed manner. So the introduction, image filtering, specifications, objective, the background, how and what the module, like what modules are getting used here, what are the functionalities, how this particular project is working, everything is in detail mentioned here. The hardware, software requirements of the project. Then here you can see the coding and its output screenshots. Everything is explained very nicely in this report, and in case you need it, you can get it from us. Simply here you can see I'm just scrolling this, so you will be getting the idea that how it looks like. This is the complete like demonstration, the the frequency filter and all, every algo and like internal details are also properly included into this report. Okay, and now I'm going to show you the PPT, that is the presentation. So in case you need, I'm having all the documentation related to this project. You can just contact and get it. So here this is the presentation of this particular project, which is like having all the related information which should be present in a PPT. The introduction, the objective, the background details of the project, what are the different modules getting used, conclusion, and different outputs, outcomes of this particular project. Everything is properly included in the report and PPT even. Here you can see. Okay then, so I hope you have got the idea that how this particular project looks like. I have already shown you the code. It is completely running and it is running very nicely. So if you want it, you can contact us. You can just contact on the given number, or you can join the WhatsApp group, which is the link is given in the chat. So you will be like simply contacting me, and you can get the project, simply the complete project with the documentation and all. I am just showing this once again to you. The mean filter, grayscaled, Gaussian filter, grayscaled, median filter, grayscaled, then the Laplacian and its intermediate results, magnitude spectrum, which is coming to the high and low frequency. This is the high one, and this is the low pass filter. Okay, now as I said, I am just going to tell you that how you will be actually installing the modules into your system. So there are two ways. Either you can install the modules with the help of terminal. Here in the terminal you can install it. You can just type pip install numpy. So numpy is the numeric Python module. In my system it is already installed, so it will be saying requirement already satisfied. But in your system it will be taking 2 to 3 minutes over the internet to get installed into your system. And pip stands for Python package installer. So with the help of this pip command you can install it into your system. The numpy module, pip install matplotlib. It is also installed in my system, but yes, you have to install it with the help of this particular command. I am again pressing enter. In my system, it is already installed, so it is saying requirement already satisfied. But in your system, it will be taking 2 to 3 minutes to get installed. Then pip install OpenCV-Python. So this is actually used to install the OpenCV module, because the OpenCV module is actually you can say coming for C, C++ and Python all. So we have to install the one which is for Python for this particular project. So here you can see it is installed. Actually it is already installed in my system, but yes, I have told you the commands. So one way was that you can install it through the terminal here. Another way, you can go towards the command prompt to install it. So I'm just coming to the command prompt, that is the DOS of our system. So here also you can just type those commands which I have told you, pip install numpy for numpy module, and press enter. Over the internet it will be installing, so please keep your internet connection on. Then pip install OpenCV-Python. This one is for the OpenCV, that is the CV2 which is written there. Then pip install Matplotlib. So one by one you have to run these commands, then only these will be getting installed. Okay, so I hope you have got the idea that how these will be installed into your system. All the things are with me. Contact me if you want them. And now I am going to tell you about the remaining stuff, the links and all which I said. So OpenCV.org is the official website of OpenCV, and its link I will be sharing in the description. Matplotlib for the visualizations in Python, that also I will be sharing. Subplot and all we have created with the help of this only. Then the NumPy, that is the numeric Python. Now the PyCharm. So PyCharm simply jetbrains.com is the official website of PyCharm. And when you are going to work on this PyCharm, you have to use the community version. Okay, because this community version always comes free of cost. You do not have to pay for it. But the professional version comes with the free trial. After 1 week you have to install it, you have to pay for it simply, and it is not required to go for the professional version. Now the community version satisfied all the requirements. It satisfies all the requirements whichever is necessary for your project simply. So here these are the details which I have told you. I will be sharing all these resources in the description of this video. And in case you need any other project, so we will be helping you out. For that also you can contact us for any project related to BCA, MCA, BTech, or your PhD level projects also. So you can contact us for developing your projects, or you can contact us to ask for any particular project. In case it is available with us, we will be definitely helping you out. To get this particular project, you can just go to the description to join the WhatsApp group which is present there. So through that you will be able to contact us to get the project, or you can contact on the given number. Thanks for watching. Like the video and subscribe the channel simply. And one more information I want to tell you, apart from this OpenCV, there are many more playlists available on this channel. Even the Matplotlib related playlist is also available. Jupyter Notebook, this is the machine learning using Jupyter Notebook. So Jupyter Notebook, how you can use, and in this particular, actually the complete Matplotlib module demonstration is given. So this link also I will share in the description, so you will be getting help out of it. And there are 8 videos. They are having multiple you can say demonstrations of the graphs, the plots which can be created using the Matplotlib. So you will be getting it from here. Even the complete Python programming playlist is present here on my channel. So here I'm just opening this one also, and I will share its link in the description. Even there are 85 videos. So in case you are a beginner, you want to learn Python in a proper way, or you are intermediate even on intermediate level, then also it will be helping you out a lot to revise the stuff in a proper manner. And multiple projects also are demonstrated into this Python programming playlist. So here you can see 85 videos are there. This also I will be sharing in the description. Thanks, and see you in the next video with another project demonstration. Till then, stay tuned and don't forget to subscribe and press the notification bell.